Hi everyone, welcome to our channel. So today we're going to discuss about a new subject, compiler design. So what basically is a compiler design? So what is a compiler? So while we learn the C programming, we basically say that we'll compile our program. So what exactly happens during compilation process? So a compiler will take source input and produces target output. So what does compiler take? So compiler takes a source input and produces a target output. So what is interpreter? Compiler will scan at a time each and every line from left to right, and if at all there are any errors in the lines of code, it throws an error. But whereas interpreter, the example of interpreter is Python language. It executes instruction by instructions. So that's the difference between compiler and interpreter. Okay, so how this language processing is done? How does this language processing is done? So high level language is converted to machine understandable format. So whatever program we give is high level language and it should be converted to machine understandable format. So HLL to MLL. So in between these high level language to machine level language, we'll get an assembly level language. Okay. So there assembler comes into picture. So these are all basics of a compiler, and the most important one is how the compilation process is done. What are the different phases of compiler? Now we'll discuss the most important topic, phases of compiler. So what are the different phases of compiler we have? The first and foremost phase is lexical analysis. Second one, syntax analysis. Third one, semantic analysis. Fourth one, intermediate code generation. Fifth one, code optimization. Sixth one, code generation. Lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, code generation. So we'll discuss each one with a diagram. So this is the diagram for phases of compiler. First, we'll have a source input. So what we discussed, so providing a source input, we will get a target output. So when source input is given to a compiler, the end result will be a target output, right? So first phase is lexical analysis, second syntax analysis, third semantic analysis, fourth intermediate code generation, fifth code optimization, and last one is code generation. So first first from source input will be taken by lexical analysis, next syntax analysis, the next semantic, like that. Finally, we'll get target output. So parallelly, we have two more. One is symbol table management, and the second one is error handler. So what exactly does it mean? So during lexical analysis phase, if any error is encountered, that should be handled by error handler. Okay. So until unless that error is solved, we can't move on to the next phase. So what is our next phase here? Syntax analysis. So during that process, if we get any error, that should be handled. So for each and every phase, error handler is common. So when all the phases are successfully completed without any errors, then we'll get the target output. And what is symbol table management? So every information will be stored in symbol table management, like the constants, variables, everything will be stored in symbol table management. So the symbol table management as well as error handler will be there in through all the phases parallelly. Okay. Now we'll see each and every phase in detail. So what does lexical analysis do? What does syntax analysis do? Semantic analysis, like that we'll discuss each one in detail. So the first one is lexical analysis. So what does lexical analysis do? So lexical analysis, so before explaining lexical analysis, we should know the role of a syntax analysis. So syntax analysis, what it will do is, it will always generate a syntax tree or a parse tree. So in order to generate a syntax tree or a parse tree, it requires some group of tokens. So until unless it has tokens it can't generate a parse tree or a syntax tree, whatever it is. So this syntax analyzer will always request lexical analyzer. So a machine is called lexical analyzer if it performs lexical analysis. A machine is called syntax analyzer if it performs syntax analysis, like that. So this lexical analysis phase, it divides the source input into group of tokens. So what source input are we providing? That source input is divided into group of tokens. Right. So how these tokens are taken? So for example, if my input is C equal to A plus B into 5. So C equal to A plus B into 5. So this input statement should be divided into tokens. So the job of a lexical analyzer to divide into group of tokens. So it gives each and every expression of it, what C is, what equal to is, what A is, like that. So detailed description. So C is an identifier. So what is equal to? So equal to is assignment operator. Now what is A? A is an identifier. Now what is plus? Plus is addition symbol. Now what is B? So B is an identifier. Now what is star? So star is multiplication symbol. Now what is 5? 5 is an integer. Okay. So in this way, what does lexical analysis do? Lexical analysis will divide the source input into group of tokens. So what I have taken here, C equal to A plus B into 5. So it is divided into tokens with a description. What is C? C is an identifier, equal to is an assignment operator, A identifier plus addition symbol, B identifier, star multiplication symbol, and 5 is an integer. Now we'll see the next phase, syntax analysis. So syntax analysis, what exactly happens is, here it's already divided into tokens, right? In lexical analysis phase, the source input is divided into tokens. So in syntax analysis, we'll construct a syntax tree or a parse tree. So it totally depends upon two values. One is L value, second one is R value. L value and R value. So L value is left value, R value is right value. So here we are taking C equal to A plus B into 5. So here before operator, whatever we have is L value, LV, and after operator, this is called RV, left value and right value. Now the operator becomes our root. So what is operator here? Equal to is our operator. And what is left to operator? C. And what is right to operator? A plus B into 5. Now take A plus B into 5 again. In this, plus is our operator and A is left value, B into 5 is right value. Okay, now what is my operator? Plus. So what is left to plus? Small a. What is right of it? I have B into 5 again. Now take B into 5. Now here star becomes our root. L value is B, R value is 5. So this is star, star becomes our root and the left value is B and the right value is 5. So this is how we construct a syntax tree or a parse tree. So what is syntax analysis here? The tokens which is already divided there, by depending upon the L value and R value, will construct a syntax tree or a parse tree. So here C equal to A plus B into 5. So here equal to becomes our root. The left of that equal to is C. So C becomes our left child. And the right child is A plus B into 5. Here plus becomes our root. The left of plus is A. And the right of plus is B into 5. And star becomes our root again. And the left of star is B. And the right of star is 5. So this is the way we construct a parse tree. So this is the second phase, syntax analysis. And coming to the third phase, that is semantic analysis. So what exactly is semantic analysis? Semantic analysis is nothing but whatever parse tree, whether we constructed, is following some semantic rules or not, whether it is meaningful or not, whether it follows the translation rules or not. Okay. So if you see clearly, as we know that C is an identifier, which we already discussed in lexical analysis. C is an identifier, equal to is assignment symbol, A is an identifier, plus is addition symbol, B is an identifier, star is multiplication symbol. So what about 5? Here simply we're saying that 5 is an integer. So what if I take 5.0? So this 5.0 will be considered as floating point. 5 is an integer, we know that, but 5.0, if compiler considers it as 5.0, it becomes float. Now it is not meaningful. So here in the place of 5, what we'll do is we'll simply say int and that will become your 5. Okay, now it is meaningful. So this is nothing but semantic analysis. Now coming to the fourth one, after semantic analysis, intermediate code generation. The fourth one is intermediate code generation. So what happens in intermediate code generation? In intermediate code generation, we'll take some temporary statements, intermediate statements, and we'll divide our source input into intermediate statements. For example, so if I say T1 equal to 5, I have taken intermediate statement T1 equal to 5. And if I say T2 equal to B into T1, now T2 is nothing but B into, in the place of T1 I already have 5. Okay, so I have taken another intermediate statement T2. Now T3 equal to A plus T2. Now in T2 contains B into T1, T1 contains 5. So what is A plus T2? A plus T2 is nothing but B into T1. What is T1? T1 is nothing but 5. So here I have taken 3 intermediate statements. And finally I say C equal to T3. If I say C equal to T3, what is C here? Equal to T3 means A plus T2. T2 means B into T1. T1 means 5. So T3 is nothing but A plus B into 5. Okay. So this is the way we'll handle the intermediate code generation. So how many statements we are taking here? 1, 2, 3, 4. So 4 lines of code. So our next topic is code optimization. In this code optimization, we'll optimize the lines of code. Here I have taken 4 lines of code. Without changing the design, we'll reduce the lines of code so that we'll get the same output as well. Okay. And the fifth one is code optimization. Fifth one is code optimization. So here I have taken T1 equal to 5. So what I will take here, T1 equal to B into 5. Okay. So T2 equal to A plus T1. C equal to T2. Now here I confine to 3 lines of code, 3 statements. So whereas before optimizing I have 4 lines of code, 4 statements. After optimizing I have only 3 lines of code. So this is nothing but code optimization. And the last phase is code generation. So in code generation, we'll use instructions to represent our source input. So that instructions are nothing but your mnemonics in which an assembly, that machine understandable format. Okay, so machine understands only the instructions. So here, if I say move 5 comma R1, it's nothing but I'm moving 5 into register 1. Mul B comma R1. So mul is for multiplying. Mul B comma R1. Now R1 contains B into 5. Now add A comma R1. So I'm adding A and R1 contains B into 5. So A plus B into 5. And finally I am moving that to C. Move C comma R1. Like that. So in this way I will use intermediate statements to, I will use instructions to represent my source input. So this is code generation. So in this way we'll generate the source input is converted into target output. So in each and every phase, if you get any error, that will be handled by error handler. So what types of errors are there? These are all we'll discuss in our next topics. Okay, and every symbol is stored in symbol table. So which is nothing but your tokens. Every sort of information will be stored in symbol table management. So these are the 6 phases of compiler. So I hope you understood the topic. So in the next class, we'll discuss more in detail about the compiler design and compiler construction tools. What are the different types of compilers? So we have incremental compiler, we have cross compiler. So what are they? So all this stuff we'll discuss in our next class. So the students who are watching my channel for the first time, I request you to please subscribe my channel and please share my videos to your friends and well-wishers, and please support our channel in all possible ways. Thank you. Thank you very much and have a wonderful day.